Good morning, everyone. Today we'll be finding zeros of higher degree polynomials. In chapter 5, we found zeros of quadratics or degree 2. Now we'll have to employ a multiple of techniques to find zeros of higher degree polynomials. So the first technique we'll use is finding zeros by grouping. Okay, so let's see here. I have a cubic polynomial, x cubed plus 4x squared minus 36x minus 144. So I'll treat x cubed plus 4x squared as one group, and then I'll treat negative 36x minus 144 as another group. Out of the first group, I can factor out an x squared, and so that will leave me with x plus 4. Now remember, as I said on Friday, you always get a hint how to factor the second group by factoring the first group. So my hint here is going to be x plus 4. And so over here I'll write x plus 4. That's my hint for factoring the second group. And then I ask myself, what do I need to multiply x plus 4 by to get to negative 36x minus 144? Well, I just have to multiply it by negative 36. So there's my sec. So I'll write negative 36. And then we find the zeros. So I have x squared minus 36 as one group, and then x plus 4 as another factor. And then I factor x squared minus 36 as a difference of squares. So x squared minus 36 is equal to x minus 6 times x plus 6, and then I have x plus 4. And so my zeros will be 6 and negative 6. And negative 4 will be my zeros. And you can certainly graph that polynomial, that cubic polynomial in decimals, and you would see the zeros 6, negative 6, and negative 4. So I want you to pause the video and then try the next one. X cubed minus x squared minus 49x plus 49. So pause the video and try that. So again, I have to treat that as a group and that as a group. I will factor out x squared. That will leave me with x minus 1. And there's my hint for how to factor the other group, x minus 1. So I have to multiply x minus 1 by a negative 49. And that will give me negative 49x plus 49, and that's what I started with. So then I group x squared minus 49 as one pair of factors, and then x minus 1 as another pair, and then I factor the difference of squares. X minus 7 times x plus 7, that will give me x squared minus 49, and then x minus 1. Those are my three factors. My three zeros would be 7, negative 7, and 1. Okay, so that's case 1, factor by grouping. Cubic polynomials. Let's look at case 2, factoring out the greatest monomial factor, then factor as a trinomial. So here I want you to notice that I have x to the fourth, x cubed, and x squared. Always factor before you factor, okay? Makes life easier. So here, out of x to the fourth, x cubed, and x squared, I can factor out an x squared. And that leaves me then x squared plus 4x minus 21, which I factor as a trinomial. Factors of negative 21 that add up to positive 4 is a positive 7 and a negative 3. So here I have all three factors. I have x squared, x plus 7, and x minus 3. And so my zeros would be 0, negative 7, and 3. Okay, try the next example. Pause the video and try the next example. Okay, so for this one here, I have x to the fifth, x to the fourth, and x to the cube. There's no number I can factor out. I can factor out only x cubed, so I will factor out x cubed. And what's left over is x squared minus 6x plus 9 equals 0. And so I'll factor x squared minus 6x plus 9. Factors of positive 9 that add up to negative 6, that would be x minus 3. This is a perfect square trinomial. And so my zeros would be 0 and 3. Let me write that. 0 and 3 would be my zeros. And again, you would see 0, 3, and 3 on decimals. All right. Let's look at the third case. Factor as a trinomial, then you factor a difference of squares or you solve for x. So here I have x to the fourth minus 11x squared plus 28. Okay, I can't factor out any x's because I don't have an x for 28. So what I can do though is like factor this as a trinomial. So I have x to the fourth minus 11x squared plus 28. So I'll think what happens if I had, so I'll think of it this way. If I had x squared minus 11x plus 28. Well, I would factor that. Factors of a positive 28 that add up to negative 11 would be negative 4 and negative 7. So factors of x squared minus 11x plus 28 would be x minus 4 times x minus 7. Well, I'll factor this fourth degree polynomial the same way. Okay, but rather than writing x minus 4 times x minus 7, I'll write x squared minus 4 times x squared minus 7. After all, x squared times x squared is x to the fourth. X squared times negative 7 is negative 7x squared. Negative 4 times x squared is negative 11x squared. When I combine the two, I get negative 11x squared, and then negative 4 times negative 7 is 28. So you factor it like a trinomial. Okay, so now I have x squared minus 4 is a difference of squares, which I can factor x minus 2 times x plus 2. But I can't factor x squared minus 7. But what I can do is I can just solve for x. So I set x squared minus 7 equals 0. Take the square root of both sides. And then I get x is equal to plus or minus root 7. So I found all four zeros. 2, negative 2, and plus or minus root 7. So pause the video and try that one. So here I'll factor. So I think as if I had x squared minus 17x plus 72. Well, factors of a positive 72 that add up to negative 17, that would be negative 8, negative 9. So I'll factor this x squared minus 9 times x squared minus 8 equals 0. And then I factor x squared minus 9 as a difference of squares. So here are my zeros. For my difference of squares would be 3 and negative 3, but I have to solve for x squared to find, or I have to solve for x to find the other zeros. So x squared equals 8. Take the square root of both sides, and then you get x is equal to square root of 8, which is equal to square root of 4 times the square root of 2. So this will be plus or minus 2 root 2. So there are my zeros. Plus or minus 2 root 2, and then 3 and negative 3. All right, and now let's look at the last case. Using decimals to find a zero, then using synthetic division to find the zeros of the quotient by completing the square. So here I have x cubed minus 8x squared minus 24x and minus 8. There's no way I'd be able to factor that by grouping. So what we do is we graph that cubic polynomial by using decimals. And here, I see that I have 1, 0 to be negative 2. My x-intercept is negative 2, 0. So 1, 0 will be negative 2. Okay, I see another 0 here, but that looks to be like a fraction or so. Or maybe even a irrational number. Don't know. But I have at least 1, 0, which is negative 2. So what I'll do is I'll use that 0 in synthetic division. So my 0 is negative 2. My 0 is negative 2. And then I'll write the coefficients. I'll write the coefficients for my polynomial. So 1, negative 8, negative 24, negative 8. So 1, negative 8, negative 24, negative 8. And then I use synthetic division. So negative 2 times 1 is negative 2, negative 8 plus negative 2 is negative 10. Negative 2 times negative 10 is 20. Negative 24 plus 20 is negative 4. And then negative 2 times negative 8 is 8, and negative 8 plus 8 is 0. And I should get a remainder of 0, right? Because I saw a 0 in decimals, which was negative 2. Well, that just means then that I was able to factor that. Or x plus 2 was a factor. All right. So now I have 1, negative 10, negative 4, and we interpret that again. We started with x cubed, remember? So when we do synthetic division, our quotient will be 1 degree less. So that would be x squared minus 10x minus 4 equals 0. I can't factor that. I could use a quadratic formula. I'll just complete the square. I find that easier. The a term is 1 and the b term is even. So I add 4 to both sides. I take negative 10 divided by 2. Negative 10 divided by 2, that gives me negative 5. And then I complete the square, draw my box, if it helps. X minus 5 times x minus 5, and when I complete the square, I'll be adding 25 to both sides. Okay, so x squared minus 10x plus 25, that becomes x minus 5 squared. That's the side of my square. So the side of that square, x squared minus 10x plus 25 is all of that. But then the side of that square is x minus 5 times x minus 5, or x minus 5 squared. Take the square root of both sides to get x minus 5 equals plus or minus root 29. And then add 5, x is equal to 5 plus or minus root 29. All right, so try that one. Pause the video and try that one. Okay, so you should have gotten a 0. I just better check here. Yep, you should have gotten a 0 of 3. So 3 was my 0 there. My coefficients, I see I have all the x terms, so that's good to remember. If you were missing a x term, you'd have to include 0, and 20, and 12. And then synthetic division, bring down to 1. 3 times 1 is 3. It's minus 8. This is negative 24. This is negative 4. This is minus 12. And this is 0. My remainder is 0. So this will be x squared minus 8x minus 4. We'll set that equal to 0. And then complete the square. So x squared minus 8x equals 4. Complete the square. Take that negative 8. Divided by 2, so this would be x minus 4, x minus 4, so x squared minus 4x minus 4x, and then when I complete the square, I'll add 16. So we have x squared minus 8x, and I'll be adding 16 to both sides. This is equal 4 plus 16. Okay, but that's just x minus 4 squared equals 20. Take the square root of both sides, and we get x minus 4 equals plus or minus root 20, which is what? 4 times 5. So this would be x minus 4 equals plus or minus 2 root 5. And then finally, x is equal to 4 plus or minus 2 root 5. So I found my zeros. 4 plus or minus 2 root 5. And then the other 0 was what? 3. And I found that by using decimal. So I found all 3 zeros. Okay, so you'll have some problems like that for homework. I would suggest you review the video. You have 4 different cases. Now on a test, we don't tell you what case to use. You just have to recognize what case to use. That's part of learning. Okay, but this is structured learning right now. On the homework, I tell you what case to use. But on a test or quiz, you don't get that luxury. You have to be able to recognize what case to use.